problem is a stand-up paddleboarder needs to paddle north across a 120-meter wide harbor. The tide is going out, creating a tidal current that flows to the west at 1.5 meters per second. The paddleboarder can paddle with a speed of 3 meters per second. In which direction should she paddle in order to travel straight across the harbor, and how long will it take her to cross? So here it is. We've set it up so that this is the angle at which the paddleboarder needs to paddle in order to end up straight across the harbor. Velocity of the person in the x direction. And to do this, all we have to do is set our component right here for the velocity of the person equal to the velocity of the current, since they're both in the x direction, just opposite ways. So we get an answer of 1.5 meters per second. And now knowing this, we can then solve for theta since we have two sides. And so now we can use sine of theta, since we know sine is equal to opposite over hypotenuse. And so sine of theta is equal to 1.5 over 3, which is also just 1/2. And now knowing the 30, 60, 90 triangle, we can find the inverse, sine inverse of 1/2, which is just equal to 30 degrees. And so now we know that our direction is 30 degrees east of north. All right, so now we can move on to the velocity of the person in the y direction. And there are two ways to solve this. You can either use Pythagorean theorem or trigonometry. I'm going to use trigonometry. So to do that, we know cosine, which is adjacent over hypotenuse, will be 3 times cosine of 30 degrees. And that, which we've worked out before, is 2.6 meters per second. So our swimmer is traveling 2.6 meters per second in the y direction. All right, so now we can use our y component to solve for how long it takes her to cross, because we know this and we know this distance. So in order to do that, all we have to do is use 120 meters, which is the distance she swims, and then divide that by 2.6 meters per second, which is her velocity in the y direction. And this gives us an answer of 46.15 seconds. And there we have it. That's our problem. Thank you.